Hello everyone, I am Keith, and welcome to Jack's Math Notebook. In this video, we're going to factor polynomials by grouping. One way to factor polynomials by grouping is to find the greatest common factor of numbers and/or variables, and then that will lead you to a completely factored form of that polynomial. And we have three big examples to show you how we can do that. And let's take a look at the first big example, in which we have 6x cubed plus 4x squared plus 3x plus 2. And we're going to group this section right here. We're going to group the 6x cubed plus 4x squared, and then we're going to group the 3x plus 2. And when we look at the 6x cubed plus 4x squared, we can factor out a 4 between the 6 and the 4. I should say we can factor out a 2 because 2 is the greatest common factor of 6 and 4. And let's put that right out here. And then we can factor out an x squared because that is the greatest common factor of x cubed and x squared. We'll put it right outside. And next thing you know, we have 2x squared times a quantity of 3x plus 2. And guess what? We have a 3x plus 2 right here, and that means that we have a common factor of 3x plus 2, and let's put that right out front. All right, and you probably ask, well, what is the greatest common factor of 3x plus 2? Well, it's just 1, and so we're just going to park that 1 right here. And so now we have that factor of 3x plus 2. Let's put it right here, and we're going to multiply that by this 2x squared plus this 1. All right, and so that is the completely factored form of this big polynomial that you see right here. And with that in mind, let's try that same logic to 7x cubed minus 35x squared plus 6x minus 30. And let's group those factors, okay? And so right here, so when we group 7x cubed minus 35x squared, we can actually factor out 7 because see, 7 is the greatest common factor of 35, or I should say negative 35 and 7 itself. And so let's go ahead and put that out there. And we can also factor out an x squared because x squared is the greatest common factor of x cubed and x squared. And we have it right here. And guess what we have right now? We have an x minus 5. Will we be able to get an x minus 5 on this side? Yes, we can do that because, see, the greatest common factor is 6 and negative 30 will be 6 itself. And as you can see right here, leaving us with x minus 5 right here. And so we have an x minus 5, and let's use that to put it right out front. And then what we're going to do, we're just going to take this 7x squared and add it to this 6 right here. And so now we can multiply these two factors. And when we do that, we would get 7x cubed minus 35x squared plus 6x minus 30 if we multiply the quantity of x minus 5 times the quantity of 7x squared plus 6. And let's move on to the third big example, in which we have 10x cubed plus 4x squared plus 5x plus 2. Using our grouping symbols right here and here, what we can do, we can factor out the greatest common factor of 10 and 4, which would be 2, and the greatest common factor of x cubed and x squared would be x squared. And that would leave us with a 5x plus 2 that you see right here. And as you can see, we already have a 5x plus 2. So the greatest common factor of between 5x plus 2 would be 1. And we just put it right out here. And so here's what we have. We have 5x plus 2 times a quantity of 2x squared plus 1. Okay, you have received a lot of significant information. And I wouldn't blame you if you need to pause the video to take a look at how to factor by grouping rather. But in the meantime, please comment, share, like, and subscribe to Jack's Math Notebook for more content. Thank you and goodbye.